KYAI Pod, the Know Your AI podcast. There's probably nothing more important than knowing this week than the OpenAI releases. It's a fire week for OpenAI. First, they rolled out their open weights model, and it performs, really well across the benchmarks. One of the leading open weights models. Whether you believe the benchmarks, where you think that it was overfitted for the benchmarks is another debate. We're not going to solve that debate today via Metrum Insights KYAI tool, but we will, kind of go look at the throughput and the latency. The quantization of this model is quite interesting. So they enabled it, quantized it down to fit on a single H100 for 120 billion parameter version. They also have the 20B. So it's pretty interesting. What Clay and I want to do is just kind of kick off, show you how easy it is to run the latest model on the latest state-of-the-art hardware with Metrum Insights. So Clay, why don't you kick us off a run?
Yeah, let's do it. Share my screen and we'll get to it. So this is going to be a run on an 8x H200. So we've got it here. I can go in and change the name real quick. Cool. Just to make it easier to identify. All right, we'll go through and make the project. We'll do a little Clay pod run. This is going to be an 8x H200 with GPT OSS. So we're going to go over here and pick our workload. This is a VLLM workload that we're going to be running on it. The hardware obviously is the 8x H200. And then we're going to go through, we need to select the correct model. So this is going to be the OpenAI. So we have the 20B as well, but we're going to be doing the 120 today. We have 8 GPUs. We'll test 128. And 265, 12, 1024 should be good. Just give us a few different concurrencies. We're ready to go. I got my Hugging Face token in there. The last thing I need to do is make sure I have the collector server version of VLLM, so the 10.2 with the GPT OSS compatibility, and then we should be good to go. So we're going to go ahead and start this run, kick it off, just double checking everything. Boom, save and execute. So now you can see the run has popped up. If we head over to monitoring, it should say provisioning. So yeah, there we go. We'll come back and check in on the results of this run after we go through a few more things.
Clay, what have you been doing in your spare time when you're waiting in between runs? Have you had some time to do a little robot engineering?
Well, a little bit. Not as much as I'd like to be doing. But yeah, we've had a lot of different things obviously on our plate. So, but we have done a bit of, at least we took the robot outside at least. We went to go see some sunshine. We wanted to, it's a beautiful summer here in Austin, Texas. So we went out to the field, tried to check out the new features that Unitree dropped in their latest firmware update. So I can show you guys a video of that as well.
Yeah, let's check it out.
So here it is. This is just a big old open field outside of our Round Rock office somewhere up the road. And yeah, we wanted to test it on grass, obviously, in case it falls. It's at least not going to blow up like it would on concrete. But yeah, here we go. So you can see the stutter there at the end a little bit.
Yeah.
But yeah, other than that, it's pretty solid. Obviously, just like anything, the faster it moves, the more unstable it is somewhat. But it's looking pretty fluid. It's like obviously running is tough to train it to do, and it's a lot, like it's pretty light on its feet. That was one of the big complaints we had with the original walking, is that it was like just super loud. Our neighbors complained, and yeah, now it's quiet. It's pretty clean.
Yeah, it's a great update as far as kind of the seamless, fluid nature of the walking and running. And yeah, you're right. It was super loud. So, well, we're waiting for these runs to complete because it'll take a few minutes. And kind of on the topic a little bit about, we're talking a little bit today about how, OpenAI quantized down the model size to fit in a H100 memory footprint. As a lot of you guys know, Llama 2 or 3B 70 billion parameter native FP16 format doesn't fit in an H100 footprint. And so having having a quantized model fit in the footprint is a great way to kind of make utilization of those GPUs. Otherwise, you got to do 2 GPUs to run one single model. And so one of the other kind of techniques that we've been collaborating with Solidigm with, as you talk about memory constraints, and everybody knows it's really incredibly expensive, the HBM memory that's housing these models. Kimi came out 1 trillion parameters, some of the state-of-the-art models just keeping it bigger. DeepSeek well over 600 billion parameters. So if you actually want to cost optimize without buying more hardware or buying more DRAM, there's another hack that we partner with Solidigm on. And we did a couple cool things. In this article, we talk a little bit about it, and we've got a full paper you can kind of download, as well as a repo that shows more. But we did 2 things. One is we can actually offload the model layers onto a solid state drive. So if you're constrained on HBM memory, you take a 70 billion parameter model, you try to load it on one H100. Another technique is to try to take the most cache, most used layers in the H100 and offload the less used layers into the solid state drive. So it's something we showed here, kind of really fun to do. We leverage RayServe and DeepSeek to make that possible. So you can kind of reduce that memory footprint required, by well over 10x. So great way to create some savings. The other thing that we've been working on is, again, with thinking about DRAM memory, and one of the biggest thoughts on DRAM use case for DRAM is, especially when you start vectorizing all your data, you start using a modern RAG stack, as is popular. You're running an agentic RAG stack, more prevalent today. DIS-ANN is a great project that has some great algorithms, for the vector searches and optimizes vector searches on solid state drives. And so one of the cool things that we found is you can dramatically kind of reduce your DRAM usage, especially if we look to these larger data sets. So get up to 57% lower DRAM usage. So huge cost savings there if you got an at-scale enterprise RAG deployment. And so, just benchmarking it with VectorDB bench, we also found, surprisingly as well, because you would naturally think, the volatile memory would be the higher performing versus the non-volatile memory. But actually, in the smaller data sets, all the way to the larger data sets, you see a higher performance, queries per second offloading as well. There is some trade-off in the indexing, time. So you got to do, you got to load those super efficient algos up front. And so that's why it's going to drive a lot higher index time. So that's a trade-off. But once you're indexed, you can get that better performance. That's more of a one-time hit. And of course, accuracy, most important, right, is recall is very similar, if not exactly the same. So really good performance. We got a fun paper. We have a repo on it with a really cool demo included, that you can kind of run these scenarios. You can turn, DIS-ANN on and off. You can turn the model offloading on and off. It's a really cool solution. And the paper's there. And I think right now, with advanced reasoning models, with the advent of AI agents are driving hundreds X more multiples of inference time compute or test time compute, because they can run 24/7 and they can talk to each other and constantly think, instead of a human having to wait for a human to prompt something. And so it's pretty incredible what workloads are driving. And with that more than 100x increase in workload, you start having to think about some really affordable ways to optimizing your deployment methodology, which memory is a super expensive component. It's a really challenging job if you're a GPU designer right now to figure out how much memory you want to put on the GPU, because it's extremely expensive versus off the GPU, especially as model sizes grow and you're constantly pressured to add more memory, but then you run into an affordability challenge. So really interesting space, really cool study with a nice repo. You guys can check that out. And Clay, I want to check in and see how our runs are doing.
Yeah, they just completed, actually. I was monitoring the logs a little bit.
Perfect timing.
Yeah, so we'll go ahead and share those back up. Just, something to keep in mind is we did only go to 1,000 concurrent requests, but, you get that nice linear graph as the concurrency grows, and then we got up to, looks like 23,000 at 1,000 concurrent requests. So for a 120 billion parameter model, it's, pretty good.
Yeah, definitely. It's kind of in that, if my memory is correct, I think it's, above what you would expect in a Llama 70B type performance envelope as well. Gosh, you'd have to run that, depending on what precision you choose, FP16 or FP8. And I've seen some pretty good results. Throughput over concurrency. Anything else really compelling?
I really want to run this through the KYAI workload, but that's kind of next steps, I think, for us. Maybe we'll share those results later on.
Well, and we gotta, not that we don't, trust OpenAI, but, I'd love to run KYAI when we get the access to the OpenAI API as well, to kind of take a little deeper dive into the GTP5 announcement.
Sure. Yeah.
Huge news in the industry, and benchmarks are coming out. Looks like it's performing well as benchmarks. It doesn't look like on benchmarks it's a material game changer on the benchmarks I'm looking at today, but you never know. And, we'll see. It's going to get released to consumers today. So everybody's going to be playing with it. Yeah.
Yeah. It's already in Cursor, so we've been playing with it a little bit already. But we're also looking at the Humanities Last Exam results. And it looks like it's still a couple percent shy of the Grok 4 Heavy. So...
and Artificial Analysis Index had it at, on their weighted model score, had it at 68 versus 67 on Grok. So wasn't massive material gains. And then there's different, obviously there's different levels, high, medium, low kind of levels of the model as well, and minimized. Yeah. Anyhow, it's going to be fantastic. What's so cool about Metrum Insights is, you can test for performance, test for accuracy. And I mean, Clay, that was just a couple minutes of test time to get, total throughput performance, latency performance, a lot of telemetry details on what it takes to run a state-of-the-art model.
For sure.
So appreciate everybody tuning in. It's going to be an amazing week this week.
Yep, definitely. All right, thanks.